Okay, so let's start the basics of dermatology with the topic structure of skin. So in dermatology, the most important questions or the frequent questions which are asked are from the topic that is basics. So we will keep in mind a detailed discussion of the basics of skin, hair and nail. So let us start with the structure of skin. Now, everybody, if I ask you a question, what are the layers of your skin? So please remember, we have three layers in our skin. The outermost is epidermis, the middle one is dermis, and the lowermost is subcutaneous tissue. Now I want everyone to please look at this image. I think it's a self-explanatory image. The part which is present at the topmost, can you see this part which is present at the outermost? This is your epidermis. This is your epidermis. The part which is present in the middle, can you see this part which contain the appendages like sebaceous gland? You have hairs coming out. So this part, this second structure is your dermis. And the lowermost part, can you see this small bubbly layer? This is your hypodermis or subcutaneous tissue layer. So this is your subcutaneous tissue layer. Or because it is just beneath your dermis, it is hypodermis. So these are the three layers of your skin. Now, first of all, my question to all of you is, what is the function of your skin? Why do we need skin? Anybody can tell me. Every organ has its own function, right? So like that, can you tell me what is the function of your skin, which is the outermost or the largest organ of your body? So please remember, the main function of your skin is it acts as a barrier. Now, why do we need barrier? Can you tell me what is the role of barrier? Why do we need barrier? We need a barrier so that we can protect our body from outside environment with respect to the allergens, pathogens. So we need something which protects our skin from the entry of allergen and pathogen. That is the first thing. What is the next or the second barrier we need? We need something so that we cannot lose the core body temperature as well as the water content. For example, in winters it is very cold outside. But does your body temperature vary according to outside? No. The reason is because the temperature is maintained by your skin. One of the part is maintained by your skin. Not exclusive, but yes, skin also play a very important role in regulating the temperature. Second, in a very drier environment or in a very humid environment, does your internal body temperature changes accordingly? The answer is no. And who is protecting? Please remember, your skin plays a very important role in that as well. So you can write along with me that there are three main functions of your skin. The most important one is it acts as a barrier. It is barrier to what? Barrier to entry of allergen and pathogen. So we are writing about the functions of the skin. The first one is function of the skin. The first one is it acts as a barrier to entry of allergen or pathogen. First, what is the second most important function? I told you it maintain or it prevent the loss of water. Prevent the loss of water. And the third one is it prevent the loss of heat. So in all three ways it is protecting our skin. Now we have three layers, I told you. We have three layers. The outermost is epidermis, the middle one is dermis, and the lower one, as I told you, it is hypodermis. Now please remember, epidermis, which is the outermost layer, the main function of epidermis is it is barrier to the entry of allergen and pathogen. Dermis, which mainly contain elastic fibers or the collagen fibers, they provide elasticity to your skin, they provide resilience to the skin. Along with that, they have a very classical extracellular connective tissue matrix which retain the water in it, and that is why it prevent the loss of water. And the hypodermis, which you can see just behind me, the bubbly layer which is present just beneath your dermis, it contains the fat cell which prevent the loss of heat. So like that, three layers have its own three separate functions. Now they can ask you in exam, which is the most important layer? Please remember, all the layers are important, but with respect to dermis, or with respect to the barrier, it is the epidermis which play the maximum role. So let us discuss epidermis a little bit more in detail. Now what is epidermis made up of? What are the epidermal layers? So please write along with me that epidermis is considered to be the outermost layer. It is made up of 5 different layers. And what is the cell of this epidermis? It is keratinocytes. So please remember, in your epidermis, keratinocytes are present, and these keratinocytes, they arrange themselves into 5 different layers. So in your exam, they ask you the question, what are the different layers of your epidermis? And it is very important exam question. In fact, in INI CET exam, they can even ask you a sequence based question. For example, they can ask you a question, arrange the layers of epidermis from outside to inside or inside to outside. So you should know what is the exact sequence of your epidermal layers. Now we have a very simple mnemonic for that. What is that mnemonic? Come, let's get sun burn. The mnemonic is come, let's get sunburn. Now what does it mean? This stands for the different layers of your epidermis. So C stands for stratum corneum. C stands for stratum corneum. L stands for stratum lucidum. G stands for your stratum germinativum. S for stratum. Just a second. The G stands for stratum granulosum. I will tell you what is germinativum. The S for stratum spinosum. And B for stratum basale. So we have 5 layers, and a very easy or a simple mnemonic to remember is come, let's get sunburn. Where C stands for stratum corneum, then we have lucidum, then we have granulosum, stratum spinosum, and we have stratum basale. Now what are the different functions and what are the alternate names of each layers is very, very important exam questions in your pre-PG entrance. So first of all, starting with the outermost layer, please remember stratum corneum is also known as horny cell layer. I will tell you why we have given alternate name to all these layers, but first of all, I want everybody to just write down what are the alternate name. Stratum lucidum is known as clear cell layer or transitional cell layer. Clear or transitional cell layer. Granulosum is known as granular cell layer. Spinosum is known as prickle cell because it is made up of cells which contain some spiny projections. So prickle cell layer. And stratum basale is known as germinative layer. It is known as germinative layer. So starting from outermost to innermost, we have 5 different layers, and let me show you a very simple image which will actually give you an idea about all these layers. It is this. So if you look very carefully, the outermost layer, this one, you can see it is stratum corneum. Now stratum corneum, it is made up of anucleated cells. We do not have any nucleus in them. And because of this, it is known as horny cell layer, because horn is a dead part of your body, right? And why it is called as dead? Because the cells do not have any nucleus in them. Second is stratum lucidum. There is a very characteristic feature of stratum lucidum that it is only present in the skin of your palm and sole. They contain some transparent material which give it a clear appearance, and that is why it is known as a clear cell layer. So stratum corneum, which is the outermost horny cell layer, stratum lucidum, which is a clear cell layer. Now just beneath, can you see this layer, the yellowish layer? It contains some granules in it. This is known as stratum granulosum or granular cell layer. And what are these granules made up of? They made up of keratohyalin, granules, which is filaggrin, and Odolin bodies, which consist of lipid. Stratum spinosum, they have some polygonal cells. And lastly, stratum basale, which is made up of tall columnar epithelial cell. So let's write in detail about each layer, starting with the lowermost layer. So let us start first with the lowermost layer, and that is our stratum basale. The lowermost layer, which is stratum basale, why it is known as germinative layer? Why it is known as germinative layer? The reason is because the cells of stratum basale, or the keratinocytes which are present in the stratum basale, they have the capacity to divide. In fact, only the keratinocytes which are present in the lower layer, they have a capacity to divide. But my question is, how the other layers are formed? If only the keratinocytes of the stratum basale are dividing, how the other layers are formed? So please remember, my students, what happens after the division, the cell from stratum basale, they ascend upwards, forming the cells of second layer from below, that is stratum spinosum. After that, it travel little more up, so stratum spinosum, then it goes to stratum granulosum, it goes to stratum lucidum if it is palm and sole, and then it goes to stratum corneum. And after stratum corneum, these cells shed. This is known as epidermal turnover. So first of all, let us discuss about the different layers, and then we will discuss what is this epidermal turnover. So starting with the first layer, which is the lowermost, stratum basale, which is known as germinative layer. Please remember that here the keratinocytes have property to divide. The question is, how much time will it take to divide? And that is known as cell cycle time. The question is, how much time the keratinocytes will take to divide? That is cell cycle time. And please remember, my students, it is 300 hours. I'm marking it as Q because it is a frequently asked question. They will ask you how much time will it take for a keratinocyte to divide in the stratum basale layer. So the correct answer is 300 hours. And what happens once it divides? It ascends upward, forming the cell of stratum spinosum. What type of cells you see? In this layer you see tall columnar cells. You see a single layer of tall columnar cells like this. You see single layer of tall columnar cells like this. You can even see it here. How does these tall columnar cells look like? These stratum basale cells, they are actually attached to the basement membrane. They are attached to the basement membrane with the help of a glue, which is known as hemidesmosome. This is known as hemidesmosome. Understood? So a little bit about the stratum basale. It is given here that we have keratinocytes which has a property to divide. We have a cell cycle time of 300 hours. We have tall columnar cells, and these cells, they are present on the basement membrane, or they are attached to the basement membrane with the help of a glue, which is known as hemidesmosome. Now once they finish their division, they go upward and they form the next layer, and that next layer is stratum spinosum. Now stratum spinosum is also known as prickle cell layer. They are also known as prickle cell layer. Now the question is, why it is known as prickle cell layer? So please remember, my students, we have discussed that in stratum basale, the cells are tall columnar. But as soon as it reaches the stratum spinosum, they become polygonal like this. They become polygonal like this. And because of these spinous projections in them, they are called as prickled cell layer. So these are the spinous projections And because of these spinous projection, it is known as prickle cell layer. Now, there are few points which you all need to remember. First of all, this is the thickest layer of your epidermis. It is the thickest layer. This is the thickest layer of your epidermis. Now, second question which they can ask you from this particular topic is, what is the content of these spinous projection? So one thing I want to discuss here itself, if you remember, I've shown you this image in the beginning of the session today. Now, what is this image? This is the image of all the layers of the epidermis. Please remember, I told you that keratinocytes, they are arranged in different layers in the epidermis. Now, the question is how these keratinocytes are attached to each other. So please remember, my students, you see a glue in between the keratinocytes of all the layer. All these keratinocytes, they are attached to each other with the help of a glue which is known as desmosome. They are attached with the help of a glue which is known as desmosome. Now please remember, in stratum spinosum, the amount of desmosome is maximum. And why it is maximum? There are two reasons. One, it is the thickest layer. Second, it contains these spinous projections, and these spinous projections, they have abundant desmosomes in it. So that is the reason why we call it as a prickle cell layer or a spinous cell layer. Okay, so let us go back to that image where we have left. Just give me a second here. Okay, so this is the thickest layer. It contains desmosomes, maximum quantities of desmosome, maximum amount of desmosomes are present. You have maximum amount of intercellular material, that is desmosome. So these are the two questions which you can get from stratum spinosum layer. Now, as we have discussed that the keratinocytes have a nature to ascend upward. From stratum basale, it reaches stratum spinosum. Now, which is the next layer? The next layer is stratum granulosum. From stratum spinosum, the cell will ascend upward, forming the content of the next layer, that is stratum spinosum. So, the next layer where the cell reaches is stratum granulosum. Stratum granulosum is also known as a granular cell layer. It is also known as a granular cell layer. It is also known as a granular cell layer. The question is why it is known as granular cell layer. The reason is because it contains two types of granules. What are those two types of granules which you see in this particular layer? One is known as keratohyalin granule, and the second one is called as Ortland bodies or lamellar bodies. So we have keratohyalin granule and we have Ortland bodies or lamellar bodies. They will ask you another question. The another question is, what is the content of each of these granules? So please remember, keratohyalin granule contain of a protein which is known as filaggrin. It contains a protein which is known as filaggrin, while Ortland bodies or lamellar bodies contain a protein which is known as, or it contains lipid, not protein, it contains lipid. The role of filaggrin, now it's very simple, it's given in the name itself. It is a filament aggregating protein. It's a filament aggregating protein. It's a filament aggregating protein. Now, what do you mean by the filament? And what filament is aggregated with the help of this filaggrin protein? So I'm giving you a very important concept, and I want all my students to please listen to me very, very carefully. As we have discussed that whole of our epidermis is made up of a cell which is known as keratinocytes. Now, keratinocytes, because they are the outermost cells, or they are the cells which are present in a structure which is outermost to the body, these cells should have a proper strength. They should be capable of resisting the tear or trauma to minor stresses. Now I'm giving you a very simple example. I hope you must have seen the construction of a building. Whenever we construct a building, what do? We first of all form the pillars. Yes or no? Now why we form pillar? Because pillar give a proper strength to that building. Pillar gives a proper shape to that building. And after forming the pillar, we form the complete structure of that building. Yes. Similar to those pillars, in our keratinocytes, we have a filament which is known as keratin intermediate filament. So just imagine if this is your keratinocyte. If this is your keratinocytes, inside our keratinocytes, we have some keratin filaments which are present in pair like this. These keratin intermediate filament give a proper strength as well as shape to the cell. These are keratin intermediate filament. These are keratin intermediate filament. It provides a proper shape, a proper strength. Now, as we have discussed, they are present in pair. They are not present singly. They are made up of two chain. If you see here, very carefully, it is made up of two chain. One is a acidic chain, another is a basic chain. So you always see that the keratin filament pairs are written in groups 5, 14, keratin 1, 10. So 5 is a acidic chain, 14 is a basic chain. 1 is a acidic chain, 10 is a basic chain. Please remember 2 points, that in the keratinocytes of the lower layer, you see keratin 514, while the keratinocytes of the upper layer, you see 110. So that is a very important point, because subsequently we will be reading about some diseases. For example, we will be reading about the epidermolysis bullosa simplex, which is a mechanobullous disorder or a congenital disease in which keratin 514 is missing. If there is no keratin 514, the stability of the keratinocytes will be hampered, and if there is no stability, obviously there will be cytolysis. Okay, so we'll be reading them subsequently with the respective topic, but please remember these keratin intermediate filament, they are present in the keratinocytes. And why these cells are called as keratinocytes? The reason is again same, because of presence of these intermediate filament. Now we understood what is keratin intermediate filament. But my question is, what is the role of filaggrin? We have discussed that filaggrin is a protein which is filament aggregating protein. And we have discussed that filament which it aggregate is keratin intermediate filament. So what exactly filaggrin protein do? I want everyone to please look at the board right now. So what happens? I told you that cell or the keratinocyte, they move from the lower layer to upper layer. That is a normal tendency. They divide in the lower layer, they move upward and forms the different layer, and ultimately they falls off or they shed. In the lower layer, that is in the stratum basale, they are tall columnar like this. They are single layer tall columnar cells. When they move upward, they change its shape from tall columnar, they become polygonal. Then when you go a little more upward, you will see that again the cell will change its shape to be more horizontally aligned, to more horizontal alignment. And once you go a little more upward, you will see that now they are flattened cells. So this change in shape of the keratinocyte, as it moves from the stratum basale layer to stratum corneum layer, this change in shape is because of a protein which is known as filaggrin or filament aggregating protein. The change in shape of the cell from stratum basale to stratum corneum is under the influence of a protein filaggrin, which we have already discussed. It is nothing but filament aggregating protein. I hope it becomes very easy and clear to all of you, very simple to understand. Clear? So let me go back, or let us go to the same part where we have left here. Okay, so we have we have filament aggregating protein, that is filaggrin, which aggregates the filament. Another point is, what is the next layer which we have discussed? The next is lipid, or the Odlin body and its content. Now, I'm sure that everybody must have used moisturizing creams, right? There are a lot of advertisement nowadays for the moisturizing creams. Have you ever seen the content of any of the moisturizing cream? Ever? Like, there are so many brands nowadays, they promote, saying that I have this type of butter, cocoa butter, shea butter, etc., etc. So we have a lot of moisturizers nowadays which are available. Now, what are these moisturizers? They are lipid. They are butter formulations. They are lipid. And what does this lipid do? Lipid make a water resistant barrier, as well as it provides a moisturizer to our skin. So even if you do not apply any moisturizer from outside, you have your own moisturizer, and that is in the form of Odlin bodies, which releases lipid. Now, with age, the amount of Odlin body reduces in your body. And if you have any elderly in your house, just compare your skin with their skin. You will feel that their skin is comparatively drier when you compare their skin with yours. And the reason why they have a drier skin is because the lipid content, the lipid which is present here, the lipid is very less as you go old. So the amount of Odlin body reduces. Okay. Now, something applied I wanted to discuss here, that what are the diseases which you get when there is decrease in the amount of Odlin bodies? The disease which you get is steatotic dermatitis. Steatotic dermatitis, very common in elderly. And what are the diseases where the filaggrin protein is deficient? We have two diseases. One is atopic dermatitis. We have atopic dermatitis. And what is the next? Anybody can think of? It is ichthyosis vulgaris. It is ichthyosis vulgaris. So these are the two conditions which you get if the filaggrin is reduced, and steatotic dermatitis is the one when the lipid amount or the lipid content of our body goes down. So these are the two features which you need to know with respect to stratum granulosum layer. Now, what is the next layer? When the cell or keratinocytes move from stratum granulosum, it enters into another layer, and that layer is stratum lucidum. That layer is stratum lucidum. Stratum lucidum is also known as clear cell layer, even transitional cell layer. So we have alternate names for the stratum lucidum also. It is known as clear cell layer, it is known as transitional cell layer. Now let us write some important points with respect to stratum lucidum. First of all, this is a layer which is only seen in palm and sole. It is only seen in palm and sole. Now, why it is called as a clear cell layer or transitional cell layer? Now, I want everyone to please look at your palmoplantar skin. Just right now, I want every one of you to please look at your palmoplantar skin. Please remember, whatever is your skin color, whether you are very dark, whether you are very light, the palmoplantar skin is always lighter compared to the skin of your other part, like dorsum of the hand or other part of your body. So I think everybody have observed that. What is the reason? Why do you have a lighter skin in your palm and sole compared to other part of the body? The reason is because we have an extra layer, and that extra layer is called as stratum lucidum. This extra layer contains a granule which is known as illudine granule. This illudine granule give it a clear or a transparent appearance or a little whitish appearance. So the reason why stratum lucidum is known as a clear cell layer or transitional cell layer, the answer is because it contains an extra granule which give it a transient or a clear appearance. And please remember, you will find this layer only in your palm and sole. After stratum lucidum, the next layer which you which you see is your stratum corneum, the last layer of your epidermis. We have already discussed that it is known as horny cell layer. We know that this is known as a horny cell layer. Why it is known as horny cell layer? Because please remember, the keratinocytes which you see in this layer, they are anucleated. We do not have any nucleus. So we see anucleated, flattened keratinocytes. We see anucleated, flattened keratinocytes in these or in this layer. I hope this is clear to all of you. Now, two terminologies, two histopathological terms which you should know with respect to your stratum corneum, which is very important, frequently asked. One is, what is hyperkeratosis? What is hyperkeratosis? And second is, the second terminology from which you can get a lot of questions. What is parakeratosis? Now, hyperkeratosis means increase in the thickness of stratum corneum. Please remember, my students, normally stratum corneum is 4 to 5 layer thick. We see 4 to 5 layers of keratinocytes which are arranged on each other. But there are some conditions, for example, psoriasis, for example, verruca vulgaris, where there is increased proliferation of the cells of the epidermis. In all these conditions, there is increase in the thickness. Instead of 4 to 5 layers, you may see 7 to 10 layers, 10 to 20 layers of the stratum corneum, and that condition is actually called as your hyperkeratosis. But what is parakeratosis? Parakeratosis is sometimes instead of seeing anucleated cells, we see presence of nucleus. The retention of the nucleus in the cells of stratum corneum is termed as parakeratosis. And why do we see the retained nucleus in the stratum corneum? Because sometimes there is such a rapid proliferation that the cell reaches from the stratum basale to stratum corneum in a very short time, such that it do not get time to get rid of its nucleus. And in those cases, we tend to see the retained nucleus. So please write down, hyperkeratosis means increased thickness of stratum corneum. Hyperkeratosis means increase in the thickness of stratum corneum. And what is parakeratosis? It is retention of nucleus. It is retention of nucleus in the stratum corneum. In the stratum corneum keratinocytes. In the stratum corneum keratinocytes, if you see retention. Now, one more question they can ask you, in which condition you see hyperkeratosis and parakeratosis. Please remember, example here in both of them will be psoriasis. There are a lot of other examples, but the one which is frequently asked, repeatedly asked in your exam, that is psoriasis. So with this, we are done with all the layers of epidermis. And I hope it is very easy and very clear. Let me check if you have understood this or not. So I will be giving you some questions. We'll be doing these questions one by one, and then we will understand that whether you have understood or not. So tell me the answer of this question. Which is the thickest layer of your epidermis? Stratum basale, stratum corneum, stratum spinosum, or stratum granulosum? Anyone can tell me what is the thickest layer? I think it's a very easy or a self-explanatory question. The answer is, it is stratum spinosum. Okay, we have read that stratum spinosum is thickest. I can make any other question, which is the outermost layer. It becomes stratum corneum. Okay, so I hope everybody have understood this thing. Now I have one more question. Let me see if you can answer this one. One more question is a very important question actually. Can you tell me the answer of this question? Can you tell me the answer of this question? Which layer of epidermis is underdeveloped in a very low birth weight infant in the initial 7 days? So actually it's a very interesting question which was asked in your exam in the past. Now think and tell me, which is the last layer of epidermis to form? Anyone can think and tell me which is the last layer? Obviously, we know one thing, that only the keratinocytes of the stratum basale has the capacity to divide. So they will divide, they will go into the different layer, that is from stratum basale, they will go to stratum spinosum. From stratum spinosum, they will go to the stratum granulosum. From there, they will go to the stratum lucidum layer, and after that, they will go to which layer? Stratum corneum. So obviously, the last layer to form is stratum corneum. Please make a note, all of you, that stratum corneum, it forms during 8th or 9th month of intrauterine life. They are usually formed at the 8th or 9th month of the intrauterine life. Now just imagine, if a baby is born prematurely, before the expected date of delivery, will you see presence of stratum corneum? Obviously no. The thing which is about to form in 8th month or 9th month, the baby is already formed, so the last layer to form will not be formed. So which layer is not developed, or it is underdeveloped in a very low birth weight infant in the initial 7 days? The answer will be stratum corneum, because this is the last layer to develop, and it usually develops at around 8 or 9 months of gestation. Clear? So I think these are the two basic questions which I wanted to discuss with all of you here. Now let us go to some other topics. So one thing we have discussed till now is that in your epidermis you see different layers of your epidermis, different layers of your keratinocytes. From lowermost to outermost, it is stratum basale, stratum spinosum, stratum granulosum, stratum lucidum, and stratum corneum. Understood? Now let me show you one thing. Please have a look on this image. This is a very important image. Please have a look on this image. Now as you move from the lower layer, you can see that stratum basale cells, they are tall columnar. They move upward, they form a polygonal cell of stratum spinosum. They move little more upward, they form the granular cells, stratum granulosum, and then they become horizontally elevated, or they become horizontally aligned, stratum corneum. We have already discussed that this change in the shape from vertical orientation to horizontal orientation is because of a protein which is known as filaggrin. So there are two changes which you see when a cell moves from the lower layer to upper layer. One is change in the shape. Second is there is loss of intracellular organelle. Can you observe this? In the lowermost layer you can see that there is nucleus, and there are some other intracellular organelles like Golgi body, then you have endoplasmic reticulum, etc., etc. Now as the cell move upward, these intracellular organelles are lost, such that when you reach the stratum corneum, even the nucleus is missing. And both these process of loss of intracellular organelle as well as change in shape of the cell, both these processes, they are must for formation of a strong barrier. And these two processes together, they are known as process of keratinization. So what is keratinization? Which is also known as epidermopoiesis, keratinization or epidermopoiesis. It has two steps. One is there is change in shape. From vertical orientation it becomes horizontal. You can see it is vertical here, it becomes horizontal here. Second is loss of intracellular organelles. There is change in shape, there is loss of intracellular organism, and both these processes are known as epidermopoiesis or process of keratinization. Now please remember, my students, if there is any problem in either of these steps, whether there is defective change in shape or whether there is defective loss of intracellular organelle, whenever you have any defect on either of these steps, or when there is defective keratinization, we use a terminology which is known as dyskeratosis. So what is dyskeratosis? abnormal process of keratinization. And in your exam you get a question that in which all diseases you get the disc keratosis. So we have divided them into three groups: the benign conditions, first is benign, second is pre-malignant, and third is malignant. So what are the three conditions? They are benign, pre-malignant and malignant condition. The benign conditions of the skin which presents with disc keratosis, the example is Hailey-Hailey disease, and Darius disease. Hailey-Hailey disease and Darius disease, they are two benign conditions which shows the process of disc keratosis. Second, so the benign conditions were the Hailey-Hailey disease and Darius disease. What are the pre-malignant conditions? We have two pre-malignant conditions which presents with disc keratosis. One is actinic keratosis. The next one is Bowen's disease. What is Bowen's disease? It is squamous cell carcinoma in situ. So Bowen's disease. And what is the malignant condition which presents with disc keratosis? It is squamous cell carcinoma. Squamous cell carcinoma of the skin. So these are some of the conditions which presents with abnormal process of keratinization. And you should all know that what are the different examples, because I've seen a lot of questions being asked from this particular topic. Okay. Now the next thing which I wanted to discuss here only, I told you that normally what happens when you move or when a cell moves from the lower layer to the upper layer, it takes certain time. So my question is, what is the time taken up by the cell from the stratum basale to reach up to the stratum corneum and to shed? This total time is known as cell cycle time. The total time is called as epidermal turnover. Cell cycle time is the division of the stratum basale. What is the epidermal turnover time? What is epidermal turnover? The time taken up by the cell to reach from the stratum basale to stratum corneum and to shed. Please remember, the correct answer of this question is, it is 52 to 72 days, which is equivalent to 8 weeks. 52 to 72 days, which is equivalent to 8 weeks. It's a very important question. In fact, we have seen a lot of MCQs which was asked in the past, what is the epidermal turnover time? They can give you the options in the form of days, they can give you options in the form of week. So the correct answer is 8 weeks. There are few conditions, for example, psoriasis. I told you in psoriasis there is rapid proliferation of the keratinocytes. They reach to the stratum corneum very fast. So in those conditions, the turnover time reduces. And I will tell you when I will teach you that particular topic, that what happens to the epidermal turnover time in the diseases like psoriasis. But normally it is 8 weeks or 56 to 72 days. In some books it says 56 days to 76 days. Some books says 52 to 72 days. So on an average, just consider it to be 8 weeks, which is the correct answer. So that is about the epidermal turnover. That is about the disc keratosis. Now coming to the different cells. We know one thing, we know that the epidermis is made up of a cell called as keratinocyte. But if I ask you one question, do you see any cell other than keratinocyte? Do you have any other cells other than keratinocytes in your epidermis? Yes or no? The answer is yes. We see 3 more cells in your keratinocytes other than or sorry, in your epidermis other than keratinocytes. So what are the cells of your epidermis? What are the epidermal cells? One we already know, it is keratinocyte. Please remember, keratinocyte, it constitutes 90% or even more. So it constitutes the majority component of our epidermis. But we do have other cells as well. And what are these other cells? These are melanocyte. These are Merkel cell. And these are Langerhans cell. So we have a melanocyte, we have Merkel cell, and we have Langerhans cells. Now let me discuss some questions which are very frequently asked from these three cells. Okay, so they do ask you the questions related to these three. Let us first start with melanocyte. So can you tell me a little bit about melanocyte? What is the function? Can anybody tell me what is the function of your melanocyte? Or why do we have, or why do we need melanocytes in our, skin? Very nice. So please write down that melanocytes, they are the pigment forming cell. Whatever color you have in your body, it's not because of keratinocytes. The color which is present in our skin is because of a cell which is known as melanocyte. So please remember, students, that it is a pigment producing cell. It is a pigment producing cell. It is a pigment producing cell. Now can you see how this cell appears? It is a dendritic cell. It has a lot of dendrites which comes out of it. Can you see a lot of dendrites which comes out of it? So it is a dendritic cell. It is a dendritic cell which is located in the stratum basale. From where it comes? Is it an ectodermally derived tissue? No. Please remember, this cell is not derived from ectoderm. It has derived from neural crest, and during the process of embryogenesis, the cell have migrated from the neural crest and has reached to our skin, that is ectoderm. So please remember, my student, that this is not a ectodermally derived tissue. This is a neural crest derivative. Neural crest derivative. All these are exam questions. Whatever I'm writing here, all of them are exam question. Lastly, please remember, with the help of these dendrites, whatever dendrites they have, with the help of these dendrites, they actually distribute the color to the adjacent keratinocytes. Now, if you look very carefully here, can you see these are some, this is the nucleus, right? This is the nucleus of your keratinocyte. Just above the nucleus, can you see these dots? These black colored dots? These are the melanosomes which contain the pigment melanin. So once these pigment containing organelle, which is the melanosome, it produces the pigment, it reaches up the dendrites, and it distributes the color to the adjacent keratinocyte, and this color then form a umbrella like covering over the nucleus of the keratinocytes, and that is how it protects the nucleus of the keratinocytes from the harmful radiations of the sun rays. So please remember that it's a neural crest derivative. One melanocyte give color to 36 keratinocytes, and this is known as epidermal melanin unit. Epidermal melanin unit, which is 1:36. Again, it's a very important exam question. I've seen a lot of questions being asked that how many keratinocytes receive color from a single melanocyte. So it is 1:36. Next is this. So you can see the image of a very dark person and obviously a very light person. So that is a dark one, that is a light one. Now my question to all my students is, which of these two have more melanocyte? If I give A to this patient, suppose the darker one is patient name A and the lighter one is patient name B, can you tell me whether this light color female or that dark male have more melanocyte? Can you answer? Please remember, my students, one very important point, that whether you have a dark skin or a light skin, melanocyte count, it remains same. There is no change in the melanocyte count. It remains same whether you are light or you are dark. Then what is the reason for that dark color in that individual? So the reason is the number of melanosomes, which is the organelle producing pigment. The melanosome number is more. Melanosome number and shape differs. More number of melanosomes, darker the color. Less number of melanosome, lighter is the color. One point is this. Second is type of pigment. So when I will be teaching you about the pigmentary disorder, I will tell you what are the two different type of melanin. We have pheomelanin and eumelanin. Eumelanin, if it is more than pheo, the color of the patient will be dark. And if the pheomelanin is more compared to you, the color of the patient will be light. So that is the difference, and I hope you have understood that it doesn't matter whether you have a lighter skin or darker skin. You always see the same melanocyte count in both the individuals. Okay, it is only the melanosome number and the difference in the shape and the type of melanin which decides the color of the patient. And with respect to the melanocytes, I think we know everything now, that it's a pigment producing cell. It's a dendritic cell which consists of all these dendrites located in the stratum basale, neural crest derivative, and the epidermal melanin unit is 1:36. Moving to the next cell. What is the next cell? We have already discussed. The next cell we have is Merkel cell. Now Merkel cell, where it is located? Now if you look at this image, Merkel cell is located at the lower part. Again, it is located at the stratum basale. What is the function of Merkel cell? If you see that here, can you see this yellow color thing which is attached to this blue color cell? So Merkel cell is actually a receptor which is attached to a nerve. And what receptor is it? It is receptor for what? It is receptor for touch. So please write down, it's a slow adapting type of touch receptor. It's a slow adapting type of touch receptor. Number 1. What else? First of all, it is a slow adapting type of touch receptor. What is the second point? Location. It is located in the stratum basale, like that of melanocyte. Next point, from where it comes. So please remember, Merkel cell is ectodermally derived tissue, like that of the other cells of skin. So it is ectodermally derived. And if I ask you a question, if Merkel cell is a slow adapting, can you tell me what is the fast adapting touch receptor of your skin? Which is that fast adapting touch receptor? Very nice, you all are right. It is the Meissner's corpuscle, which is the fast adapting. Merkel cell is a slow adapting type of touch receptor. And three questions, that it is ectodermally derived and it is located in the stratum basale. So that was the next cell, and the last or the fourth cell of your epidermis is your Langerhans cell. A very, very simple cell, the Langerhans cell. Now I don't know whether you can see or not. Langerhans cell is a cell. You can have a look over here. Langerhans cell is located in the stratum spinosum layer. What is the role of Langerhans cell? What is the role of Langerhans cell? It's an antigen presenting cell. It's an antigen presenting cell, similar to the melanocyte. It has dendrites, so it is a dendritic cell. Location we have already discussed, stratum spinosum. And the last point which I want to discuss is, what is the function? Please remember, I've told you that its function is in antigen presentation, immune surveillance. So listen to me very carefully, what actually happens. Now I'm giving a hypothetical example first. Now what happens if there is a fight in your colony, or whatever place you are staying, if there is a fight, local fight outside your house. So who is that first person who come to the site? It is the policeman or the havaldar of that particular area. So that policeman will come, he will see what is happening, and he will take, suppose two people are fighting, he will take those two people and will take them to the local police station. Yes. So there is a havaldar who took the culprits to the local police station of that particular area. We have police stations in different areas, right? So those two culprits were taken to the police station by that havaldar or that policeman. So what is that policeman doing? It is just presenting those two culprits to the police station. And who is sitting in the police station? It is the inspector. So that policeman or that havaldar is not the one who decide the fate of these two culprits. It is the inspector who will decide what will happen to those two individuals. The role of that havaldar is only to take those two persons to the police station, and in the police station it is the inspector who will decide. Same thing happens in our body. If a allergen or a pathogen enters in your body, it enters the skin obviously because skin is the outermost layer of your body. Inside your skin there is a havaldar sitting, and that is your Langerhans cell. Langerhans cell will take that allergen or pathogen to the regional lymph nodes, which is the police station of our skin or our body. So antigen presenting cell, the Langerhans cells, will take those allergen pathogen to the regional lymph nodes, and in the regional lymph node it is the naive T cells which decide whether to form a cytotoxic T cell and to kill that allergen or pathogen, whether we have to form a effector T cell, helper T cells, etc., etc. So very simple, that Langerhans cell just play a role of antigen presentation. To which cell? It is the T cells. Okay? Very simple, very clear. The next is, what is it derived from? It is a mesodermally derived tissue. It is derived from mesoderm. It is present, or it is actually derived from the cells coming from the bone marrow. So it is a mesodermally derived tissue. So with this, we are done with the cells of the epidermis other than the keratinocytes, and we have already discussed that keratinocytes constitute the majority of the component. Rest all cells form a very minor component. It is mainly the keratinocytes which forms the 90% of our skin. So that is all. Now let's do some questions before going to the next part. It actually depends upon what we have already discussed. So can you tell me the answer of this question? The question which is present on your screen. Melanocytes are present in, what will be the answer? Very simple, they are present in the stratum basale. We have discussed that it is the part of the lowermost layer of the epidermis, that is stratum basale. The next question, what is the normal turnover time of your skin, or what is the epidermal turnover? Yes, it is 8 weeks. Again, very simple. I told you 56 to 72 days or 52 to 72 days is the answer. Next question. The next question is, what is the main cell of your epidermis? Which is the main cell of your epidermis? It is the keratinocytes, which constitute the 90% of the total cells. And the last question is, the cell which is responsible for immune surveillance, the cell which is responsible for the immunosurveillance in your skin. It is very nice. It's a very simple one. It is your Langerhans cell. So that is about your epidermis, which is the outermost layer of your skin. Little bit about the junction. What is the junction made up of? The dermoepidermal junction made up of. So we have a very simple image, a very self-explanatory image. Now if you look very, very carefully, let me go to this part. Can you look at this part? No, not this part, this one. This part which is forming the top, this whole thickness, it is your epidermis. Can you see that? Now we are actually splitting the skin at the dermoepidermal junction. If you look at the dermis here, you can see that there are some projections which are going up. There are some projections which are going up. The part of the dermis which are going up, it is your dermal papilla. And the part of the epidermis which is going down is your rete ridges. So let me explain what exactly this image shows. Now the dermo-epidermal junction is not smooth like this. You never see dermo-epidermal junction like this. No. Then how is our dermo-epidermal junction? It is like this. Can you tell me why? Why we do not have a straight like this? Why we do not have a straight dermo-epidermal junction? Why it is ups and downs? Simple logic. Have you seen tires on the road? They're never smooth. You never see the tire of your motorbike or your car which is smooth. No. It always have some ridges, some gyri, sulci sort of appearance. And same thing on the road. If you have seen, we never make a road very smooth. The reason is, if we make the two surfaces smooth, when we give a tangential force, there is a good probability that it slips off. So our skin has a lot of external pressure, lot of trauma, minor trauma. If God have given a smooth surface, there is a very good probability that our epidermis moves over our dermis. But that usually doesn't happen. The reason is because we have some upward projections which comes out of our dermis, and we have some downward projections which goes down from our epidermis. So these downward projections are known as rete ridges and the upward projections are known as dermal papilla. And they form a very strong bond between each other which prevent the slipping off of the epidermis or dermis on each other. Okay, so let us make it a little more clear. I am coloring the dermis with pink. So if you see, there are some pink color which is going up in the epidermis, right? So those upward projections of your dermis is your dermal papilla. The upward projections are dermal papilla. The upward projections are the dermal papilla. This one, this particular one. While the downward extensions, these, what are these? These are your rete ridges. So we have dermal papillas and rete ridges which forms a dermo-epidermal junction. Now moving to the next part, that is dermis. It's a very, very important part because it is the thickest part. Please remember, in our dermis we have a lot of things. We have cells, we have fibers like collagen fibers, elastic fibers. So coming to our dermis, this is our whole image of the dermis. I'll explain you in detail, don't worry. First of all, I want all my students to look at this image. You can clearly appreciate these are the different layers of your epidermis. We have a horny cell layer, which is the anucleated cell layer. Just below you can see this layer is your granular cell layer. Then we have a prickle cell layer which is made up of polygonal cells, and we have a single layer which is formed of the tall columnar epithelium which is stratum basale. Just below your epidermis we have basement membrane, and below your basement membrane you have dermis. Now can you see dermis have a lot of things inside it? We can see that there are cells on the superficial layer. Can you see? We have cells on the superficial layer. In the deeper layer, you can see that we have elastic fibers and we have collagen fibers. So lower part is more dense. The upper part is more thin or less dense. If you look at this image, the upper 1/3, the upper 1/10 of the dermis, which mainly contains cells, it is papillary dermis. And why we call it as papilla? Because papillary dermis, because it is the part which forms the dermal papilla. This is your reticular dermis. The lower 9/10. So just write down that this is your upper 1/10. and this is your lower 9/10. The upper 1/10 is mainly made up of cells, and can you see, I can just come here to show you the different cells. We have mast cells, we have dermal dendrocytes, we have macrophages, and we have fibroblast. So these are the 4 types of the cells which you see in the upper part of your dermis, which is the papillary dermis. In the lower 9/10, you mainly see fibers of, or you see net of collagen fibers and elastic fibers. So can you see, you have a lot of net, like wavy sort of a pattern or a reticular type of pattern, which is made up of fibers of either the elastic tissue or the collagen fibers. Please remember, collagen fibers, they are present in a more quantity compared to that of elastic fibers. So collagen fibers are more compared to elastic fibers. We have different type of collagen fibers. Among all the types of collagen fibers, it is the type 1 which is more common or maximum, followed by collagen type 3. And sometimes they ask you about the ratio, so please remember it is 4:1. The ratio between the collagen type 1 and collagen type 3 is 4:1. Okay, so that is brief. We will discuss about the different type of collagen later in the detail when we will discuss about the different diseases. But for now, just remember that dermis, it has 2 components. The upper 1/10 is a papillary dermis. The lower 9/10 is a reticular dermis. Now, another thing which I want all my students to please have a note in this particular image. Look at this image first. Can you see that in this whole image, in the dermis, you see a lot of other component also. For example, can you see this blue thing which is going upward? This is your, what is this? This is your sweat gland. This blue thing which is going upwards, so this is a gland, this part is your gland, and the duct is draining directly onto the skin. What is this? This yellow color structure is your sebaceous gland. And what is this long black thing? This is your hair. So in your dermis, you see a lot of skin appendages which include sweat glands, sebaceous glands, and your hair. Other than this, can you see this blue and red thing which is going upward, which is forming a net here? This is your blood vessels. And another thing is, can you see this green color thing? This is your nerves. Please remember, my students, blood vessels, nerves, they are only present till your dermis. We never see any blood vessel or nerve in your epidermis. Then how epidermis receives the nutrient supply? It receives its nutrient supply from a simple diffusion through these net of the papillary dermis blood flow. They just diffuse very, very slowly and you get the nutrition in your epidermis. So that is about the basics of your epidermis and dermis.